Hold on 1 minute. So let's try and solve this. This is the May June Summer 18 question paper 2. We're going to do the theory paper first. Uh, and let me check. Okay, that's fine. Uh, starting with the first question. You have, I mean, this is about inorganic chemistry, and we can quickly go over this. I'm going to try and send the inorganic chemistry notes as well for you. The first one is you have to write the reaction of magnesium with cold water. So I'm just going to do that. It's Mg plus H2O, and it's going to produce MgOH2 plus hydrogen gas would be given off. You can balance this equation, probably just 2 over here, and suggest why the solution is cloudy after the reaction with cold water, magnesium with cold water. The reason it's cloudy is because MgOH2, if you remember the solubility of this compound, this question is related to group 2. If you remember the solubility of this compound, magnesium hydroxide is not, MgOH2 is not very soluble. And group 2 compounds, they always have a white precipitate, so not very soluble. So some MgOH2 precipitate would be formed. It's just a 1 mark question. You can write that some MgOH2 precipitate would be formed. The next one is group 2 elements, including magnesium, react with oxygen and with dilute hydric acids. There are trends in both physical and chemical properties of the elements and the compounds down the group. Reactivity generally increases from magnesium to barium. Explain why there's a general increase in reactivity from magnesium to barium. Because they are metals, and metals like to lose electrons. They always like to lose electrons, and they like to form positive ions. That is how they react. So why does barium lose electrons easily? Because barium is a bigger atom. So I mean, you're going to talk about down the group. So down the group, it becomes easier to lose electrons. Why? It becomes easier to lose electrons, and the reason for that is that down the group you have bigger atoms, and the outer electrons are more shielded, so they're much further away from the nucleus. So these are the two things that you're going to write. That it becomes easier to lose electrons, and you have bigger atoms, or you can talk about the radius of the atom, that the atomic radius increases down the group, or you can say that the distance of the outer electrons, it increases, and the electrons are more shielded, so which is why it's easier to remove electrons. The next one is give 2 observations for the reaction of magnesium with oxygen. Write an equation for this reaction, including state symbols. Now, the equation must come, I mean, it should have been below this. So it's Mg plus O2, and it's going to form MgO. The first thing is that a white solid is going to be produced. And let me actually take out my notes as well, just to show you uh, the group 2 notes. Just give me 1 second. TK should be in AS. Okay, I'm going to send this on WhatsApp, and I'm going to share these notes with you. Probably these ones. No, not just one second, not these ones. Okay, maybe just one second checking. Okay, these ones. Actually, I'm going to send these notes to you. Most of it is just mainly reactions that you have to memorize about melting points, CK period 3, which one conducts electricity, what are the reactions with water. That's group 3. Sorry, this is period 3. The common oxidation states and the acid-base behaviors, the reactions of chlorides with water. So we'll go over them in class later on. Uh, but where is group 2? So this is where group 2 is. Uh, this is all about reactions with water, which we are doing right now. Uh, and they're talking about magnesium's reaction with oxygen. So all group 2 compounds which are formed, they're going to be white in color. And you also have to remember the flame colors as well, because the reaction with oxygen is going to produce a flame. So there's going to be a white flame that's going to be produced in this reaction. So you have to remember the flame colors of all the four elements, uh, apart from radium, which is radioactive and it's very rare. The other ones, the flame colors, the reaction with oxygen, that has to be remembered as well. So coming back to this one, the other thing would have been the bright white flame. Okay, is this clear? Ethan, Mohammed, is this clear? Bazga, is this clear?
Yes, sir.
Yes.
So the next one is write an equation for the reaction of magnesium with sulfuric acid. Again, this is O-level stuff. It's Mg plus H2SO4, and it would produce MgSO4 plus H2. Now suggest why there's a general decrease in the melting points of the elements down group 2. Now this one is about melting points. Why group 2 melting points decrease down the group? Now the explanation for that is it's a 3-mark question. They're all metals, and metals have positive ions in a sea of free moving electrons. So if I draw a structure of a metal, it's going to be all metal atoms. They tend to lose electrons and they tend to form positive ions. Since this is group 2, so all of them would be forming plus 2 ions. Uh, and they would be losing, each one would be losing 2 electrons each. So they would be delocalized electrons. So it's going to be a giant metallic lattice with free moving electrons. Why is there attraction? Because they have delocalized electrons which attract the positive ions. So there are a bunch of delocalized electrons which are attracting the positive ions. So the electrons are acting as a glue. They're keeping the whole structure together. The negative electrons in the middle, they attract all the positive ions. So the positive ions attract the electrons, and the electrons attract the positive ions. Okay, is that clear to everyone? Minail, is this clear? Aiza?
Yes.
Okay. Acha,
Yes, sir.
so the issue is what happens when you move down the group? What happens when you move down the group is that as you move down the group, the size of the ion increases. The ion would still be plus 2. So I'm just going to write positive ions. And remember, all types of bonding, this happens in all types of bonding, whether they're covalent or ionic, that if the size increases, the ions would be further apart from each other. The positive charge would have a lower charge density. So the positive charge has lower charge density. I mean, it's the same plus 2 charge. Smaller ions, they're close together. They would be more strongly attracted. Bigger ions, they would be further apart. Uh, so the electrons and the positive ions, they would not be attracting each other that strongly, which is why melting points are going to decrease. I'm going to open the marking scheme just to show you how the answer is written, because I've already filled up the space. One second, is this? So this one. So they're saying any two from that the cation size increases, radius increases, or the size of the atoms increases down the group, and the charge is constant or decreasing charge density. Uh, the number of delocalized electrons, they pretty much remains the same. So you just have to write 2 points. So you could have written any of the 2 points and would have gotten the mark. The other mark was about the decreasing strength, uh, decreasing attraction between the positive ions and the delocalized electrons. TK, we talked about that as well. So there were you had to write 3 points down the group. The charge density decreases because the cation size increases, which is why the delocalized electrons and the positive ions they don't attract each other a lot. So you had plenty of lines to describe this. Okay, make sure try writing this and comparing it with the marking scheme answers as well. Most people they don't practice writing answers a lot. Okay, is this clear? Basa, is this clear?
Yes, sir.
So now this the next one. The next one is define the term relative formula mass. Instead of writing the definition, I'll just uh, okay. So I said now one thing about this, and this needs to be explained. It's the mass of an atom compared to or ions what compared to 1/12, or you can simply write uh, the mass of carbon 12 compared to carbon 12. I mean, over here they're written that it's the mass or formula unit molecule. Neither just I mean, just one second. Let me write this one. How are the mass divided? It's the mass of the molecule compared to 1/12 the mass of carbon 12. Okay, that should do it. But one thing that needs to be written over here is that it's the average mass. Okay, that's very important. That it's the weighted average. Yes, this is where I wanted to find this out. It's the weighted average. Uh, One thing about formula mass, and whenever you see this term relative, okay, so it's the average mass because remember you have isotopes as well. Whenever you see the term relative, that means you're taking out the average mass of a molecule. For example, a Cl2 molecule can have many different molecular masses or formula masses. It could have 71 if it could be 70, it could be 72, or it could be 74 because there are two types of Cl. There's 35 and there is 37. So whether both Cls are 35, that would be 70. Whether they're both Cls are one of the Cl is 37, that would make it 72. Or if both Cls are 37, then that would make it 74. So the molecules usually have different masses. So whenever you see the term relative, that's the average mass. And another thing about this is there are two things. There is relative molecular mass, and then there is relative formula mass. Formula mass is the term that's often used for ionic compounds. Uh, I mean, there's no difference between them. Formula mass is used for ionic compounds because ionic compounds are giant structures. I mean, they don't have a specific size. I mean, if you have NaCl, then the NaCl molecule, the ion or the ionic lattice is 58.5. When you talk about the formula mass, it's the formula of the smallest unit because in NaCl it's a giant lattice. You could have billions of sodium ions and billions of Cl ions all attracting each other. A sodium ion would be attracting a Cl ion, and the structure would continue. It would be a giant ionic lattice. But molecules have a very fixed formula. For example, if you have a CO2 molecule, there's only one carbon and there's only two oxygens in it. You don't have more than that. Uh, so when you talk about ionic compounds, you're talking about the smallest unit that's possible. Because the actual structure would have a lot of sodium ions and a lot of Cl ions, and the crystals would all be of different sizes. Do you get this point? Isa, is this clear? Ethan, is this clear?
Yeah.
Yes, sir.
Yes.
Okay, so just a few things about this. Uh, Relative molecular mass, because people tend to mix things up. Relative molecular mass, it's only for molecules, remember that. Simple covalent molecules. Formula mass, that's usually for I mean, this term, they pretty much mean the same thing, but that is usually reserved for ionic compounds. And ionic compounds have giant structures, so you look for the mass for the smallest unit that is possible. Uh, and whenever you see the term relative, it's always the average mass. So the proper definition over here is that it's the average mass of the ionic compound compared to 1/12 the mass of carbon 12. And you have to use the term average, okay, whenever you see the relative mass. Next one is draw the dot and cross diagram of an ammonium ion, show outer electrons only. So ammonium ion is where you have a dative bond as well. There's an N which is surrounded by, and you have to draw a dot and cross diagram. So it would be surrounded by four hydrogens. N usually forms three bonds. So on all three sides, it's bonded to three hydrogens. On the other side, it has a lone pair, but that lone pair ends up attracting an H plus one ion, which is why this entire thing gets a plus one charge. So over here, there's a dative bond. In this, I've actually switched the symbol so you can correct this. The dots are for nitrogen. I've done it the other way around. So this one is a dative bond. What's a dative bond? A dative bond is one where both electrons are coming from the same atom. So H plus one is not contributing anything. The H plus one gets attracted to the lone pairs on nitrogen. So this one over here is a dative bond. And after that, he's talking about the shape of the ammonium ion. So there are four bonds. Whenever you have four bonds, the shape is going to be around the ammonium. It's going to be tetrahedral. It's going to look like this. It's going to be tetrahedral, and the angle would be 109.5 degrees. Okay? Is this clear to everyone? Minail, is this clear? Abba, is this clear?
Yes.
So then he's talking about in aqueous solution, the ammonium ions act as weak Bronsted-Lowry acid. Explain the meaning of the term Bronsted-Lowry acid. Uh, and there are two things. One is Bronsted-Lowry acid, and the other thing is weak, and you have 2 marks for that. An acid is a proton donor. I mean, the definition is proton donor or produces H plus one ions. And weak means that it partially ionizes or weakly ionizes. I mean, it does this thing, but it does this thing weakly. So the molecule partially ionizes and produces protons. What would be the equation for such a reaction? And they're asking for the equation of ammonium ions with water. And remember, the ammonium ions are the ones that are acting as acids. I mean, they've already said that they're acting as acids. So NH4 plus 1 is going to lose an H plus 1. And the other thing is water. So you have a water molecule, H2O molecule. So if NH4 plus 1 loses an H, it becomes NH3. And the other one would then be acting as the base. And it would be gaining. So if one thing loses H plus 1 ions or loses protons, the other thing would be gaining, it would be gaining H plus 1 ions. So your products are going to be these two. Why is H3O plus 1 formed? Remember that in reality, what happens is that water can form dative bonds as well because water has lone pairs, two of them. So if it sees an H plus 1 around, the lone pairs are going to attract the H plus 1 and they would end up forming a dative bond to form an H3O plus 1 ion. So every time, whenever you hear the term H plus 1 aqueous, a lot of times in O levels and even in A levels, you see this term H plus 1 aqueous. There is no H plus 1 aqueous because all the H plus 1 ions, usually if they are present in water, they form dative bonds with water and they form this hydronium ion. So this H plus 1 aqueous is most of the time it's actually H3O plus 1 aqueous. Because H plus 1 aqueous ions cannot really exist in water. They quickly are captured by the water molecules to form this hydronium ion. Okay? Is this clear, Brad? Is this clear? Ethan, is this clear?
Yeah.
Yes. So what will be the state symbol for NH4?
Aqueous है, it's all aqueous.
अच्छा ठीक है सही.
ठीक है. Uh, including state symbols भी कहा हुआ है, so you have to be careful with that. ठीक है, read the question properly. This H2O would be liquid. I mean, you don't write aqueous for that. NH3 would be aqueous, and this would be aqueous as well. Next question, it's about moles. The question is, um, we'll read the question later. The first thing is he's asking us to balance the redox reaction. How do you end up balancing a redox reaction? In any redox reaction, electrons gained and electrons lost, they must be equal. So they have to be made equal. Mn over here is +7. Okay, you can do the math. There's oxygen, which is -2. How do you calculate oxidation states? Mn is unknown. Oxygen is, remember, -2, and there are 4 of them. So you add them up, and they should be equal to the total charge, which is -1. If you solve for x, you're going to get +7. So that's how you get Mn +7. About the other ones, Fe is already +2, that's given. H is +1, Mn is +2 over here, and Fe is +3. So what happens now? The number of electrons lost and gained, they must be equal. Mn is changing oxidation state. How much? It's changing. It's getting reduced. It's going from sorry, this is wrong. I mean, I should be pointing to Mn. Take this one. Mn is getting reduced from +7 to +2. That means a total of 5 electrons have been gained. And Fe, on the other hand, is getting oxidized and it loses just 1 electron. It goes from +2 to +3. So to make the number of electrons equal, I should multiply the top one, the oxidation part, by 5. So there should be 5 Fe's to balance out the electrons. The electrons lost and gained, they're going to get balanced if I multiply Fe by 5. Okay, Mohammed Ethan, is this clear? Abba, is this clear?
Yes.
Yes.
So that's pretty much it. That's what you have to do when you're balancing a redox reaction. Now balance the other atoms like the normal way. So how many oxygens do we have? You have 4 oxygens, so there would be 4, I think, water molecules, and that leaves you with 8 hydrogens over here. So there would be 8 H plus 1. So the things that are not getting oxidized or reduced, they're going to be balanced in the normal way. So state the role of Fe plus 2 ions in this reaction. So Fe plus 2 is acting as a reducing agent. Why? Because it gets oxidized. It gets oxidized, it loses electrons, and it reduces the other substance. So anything that gets oxidized is acting as the reducing agent. Now you have the reaction happening, and the first thing is, as a now we have to actually read the question. So they're saying that there's this thing Mohr salt, and it has all these things. I mean, this is Mohr salt. And X represents the number of moles of water. So the X is the number of moles of water. Student wanted to determine the value of X and 0.784 grams of the hydrated salt. So you're using 0.784 grams of this thing. And he turned it into a solution. And all of the solution was titrated. So this solution that has all these things in it was titrated with potassium manganate, and you can figure out the moles of potassium manganate, right? Because the volume is given and the concentration is also provided. So they are asking for the moles of magnate 7. Concentration is given, it's 0.02 mole per dm cube. Achha, be careful with significant figures. Remember, if it's written 0.02 followed by 2 more zeros, make sure that you also write that even in your rough working, because that shows that you care about the accuracy. I mean, the 2 zeros that are followed after the initial two, that shows significant figures. That means that the value is accurate up to this point. Beyond that, it's not accurate. So you don't know what comes after that or even after that. But your accuracy is up to this point. So make sure even in your rough working, don't write this as 0.02. it would be written as 0.0200. Three significant figures in this case. And the volume is 20 cm cube. So we'll try to find the moles. Moles would be concentration times volume. So 0.0200 multiplied by 20.0 divided by 1000. It should be in dm cube, and the moles would come out to be. Let me just. So does anyone else have a calculator? It's 0.02 multiplied by 20 and divided by 1000. So that gives me as in 0.000400 moles. Okay, remember, if your values are accurate up to three significant figures, your answer should be accurate up to three significant figures as well. So make sure you add the two zeros at the end. And so then he's asking about the moles of Fe2 plus. What have we done so far? We've found the moles of MnO4. So the moles of Fe are going to be 5 times that. According to the equation, it's 1:5. So I just need to multiply this by 5, and I'll get the moles of Fe. So doing that would give me 0.00200 moles. And make sure you write the working multiplied by 5. I mean, that's the moles of Fe. N usually represents Fe. Sorry, N represents moles. So it's N Fe2 plus, and that's what your answer is. And you found the moles of Fe. Next part is calculate the relative formula mass of this. So you found the moles of Fe, and by default, you've actually found the moles of this entire thing. Why? Because one of this compound has one Fe. I mean, the ratio. I mean, this has one Fe. So if you found the moles of Fe, the moles of this compound would be exactly the same, and our moles are 0.002 moles. So that's your moles. You also know the mass. The mass was already calculated initially, right at the beginning of the question. They had asked us that it was 0.784 grams. So we know the mass. So this one is 0.784 grams. So how do you find the formula mass? It's going to be, the MR would be moles is mass divided by MR. Moles is mass divided by moles. So it would be 0.784 divided by 0.00200. So 0.784 divided by 0.002, and that gives me 392. The last part is the very last part. I mean, you can probably do this on your own. It's going to consume a lot of time. You have to find the value of x. So the value of x would be, you sum them up, and they should be equal to 392. So it's going to be NH4 twice, so that's 18 into 2. Plus there is Fe, which is I think it's I mean, I should have a data booklet as well. Yeah, is this question clear to everyone so far?
Yes, sir.
Yes,
Yep.
sir.
Yes.
So 1 second, let me. I said, the reason I'm opening, I know what Fe is, but the reason I'm opening the data booklet is that when you're solving a moles question, make sure you use the exact value even in your calculations. The periodic table is 1 second. This one. So even in your working, you have to get these values correct. Fe on average, we usually take it as 56, but it's actually, I mean, the exact value is 55.8. So even in your working, you go with the exact value. I mean, most of you people, for example, if you're doing MG by memory, you would know that it's 24, but the exact value is 24.3. So make sure you use the exact value. So this one is 55.8. So it's 55.8, and then Then you have SO4, which is 32 plus, that's 16 into 4, that's 96 into 2. And then there is X multiplied by water is 18. And this entire thing should be equal to 392. So you can solve this and you would be able to find the value of X. So I'm not sure. I think you'll find the value of X.
Sir, in the above part, why did you take matlab, considered moles of iron and mass of iron to find out the relative formula mass?
How could I do that?
No, you took moles of iron as 0.002
Huh?
and
Lekin,
you took
lekin it would be the same as the moles of this compound. Na? Okay, one of this compound produces one iron, right?
yes.
So the moles of iron and the moles of this compound are going to be exactly the same.
Acha, because they're in the ratio 1:101.
Huh, matlab if you had 10 compounds of this, you would have 10. I mean, how many irons would you get out of it? 10 irons, right?
Acha, all right.
So you found the moles of iron. Matlab the equation, the reaction that they gave us, matlab the initial reaction, we found the moles of iron, not of the compound. वो तो we figured this out at the end that the moles of iron and the moles of this compound are going to be exactly the same. Okay, where was all the iron coming from? Or where was all the Fe2 plus coming from in the solution? Because you dissolved this compound,
Hmm.
and that's where you were getting the Fe2 plus, right?
Hmm.
0.002 moles, right?
Ji.
So one compound would produce one Fe, so the moles of compound would be exactly the same.
All right.
So we found the moles of this compound. We knew the mass of this compound, what initially they had given us. So we found the MR, which came out to be 392. Okay, and the last thing is you just find the value of X at the end. I said now, is this clear, everyone? Minail, is this clear? Acha, so this one, acha, we can actually try and do some of the. Wait a second, let me just check. So from the third question, we can try and do this one. Just one second. Most vehicle fuels contain hydrocarbons and they obtained from crude oil. State the name and type of reaction that hydrocarbons undergo while when they're being. I mean, this is a simple question. What is the name of this reaction when they're used as fuels? What's the reaction called?
Oxidation.
No, not oxidation. I mean, it is
No.
oxidation.
Combustion.
It's combustion. ठीक है. I don't know if oxidation would be. I mean, it should be acceptable, but it's actually combustion. Write an equation for the reaction of octane as fuel. So you just have to C8H18 and you just burn it and it produces carbon dioxide and H2O and you can balance it. 9 hydrogens, 18 hydrogens, 8 carbon dioxides, and you can count the oxygens. That's 16 plus 9, that's 25. So it's sorry, one second. So it's where's the so it's going to be 25 divided by 2. And you can write the states. This is probably liquid. Octane is liquid. It's petrol, gas, and liquid. Next one is supply of material suitable for use as fuel directly comes from crude oil is not sufficient to meet demand. A process is carried out to make some of the larger hydrocarbon molecules more useful. This is cracking of long chain hydrocarbons. So I'll just briefly explain what cracking is. That you have large hydrocarbons. Now the problem with large hydrocarbon is that they have high melting and boiling points, which means they are probably solids or semi-solids. They are probably wax-like, and they're going to be because they have more van der Waals forces. They attract each other very strongly, and they're going to be very very viscous, and they're going to be less flammable. So not because they don't mix well with oxygen, because they are already strongly attracting each other, which is why they don't burn very easily. So you crack them into smaller molecules. How do you crack them? You use SiO2 or Al2O3 catalyst, which is obtained from minerals called pumice or zeolites, and the temperature is kept above 450 degrees centigrade. So that is what cracking is. I mean, they just wanted to know the name of the process, so it was cracking, and you got smaller molecules, which were very, very useful because they had the opposite properties: low melting points, less viscous, and more flammable. Next one is the next thing is we're going to try and draw the formula of a polymer that is formed from butene. Okay, we haven't done this in class, but you've done this in O levels. So I'm just going to explain this how a polymer is going to be formed from butene. But is four carbon atoms. Two ene means that there is a double bond on the second carbon atom. So this is but two ene. You can add in the hydrogens. So there would be three hydrogens over here, and there would be one hydrogen here, one hydrogen over here, and there would be three hydrogens with this carbon atom. Now, to draw a polymer, and this is known as addition polymerization. Alkenes undergo, we did addition reactions in class, addition polymerization. Okay, so they form addition polymers. What happens in addition polymers is, actually, they had asked about this. I mean, this is the answer to part 3. And so, what happens in addition polymerization is that the first thing is redraw butene. The rule is not to draw anything on the right side or on the left side of butene. So what you're going to do is you're not going to break the molecule, you're just going to twist it around. Bring the CH3 or bend the CH3 downwards. This other CH3, bend it downwards. There should be nothing on the left or right side of the double bond. So again, I'm going to redraw this. There's an H and another H, and there were CH3s over here. I'm just going to point them downwards instead of drawing them on the right side. And this one also I'm pointing them downwards instead of drawing them on the left side. TK, is this clear? Mohammed, is this clear? Ethan, is this clear? Aiza?
Yes.
Baba, is...
Yeah.
Yes, sir.
So the next part is easy. You just have to let me up this. Now the next part is easy. You just have to draw more of these, more of the same. They had just asked us to draw one repeat unit. Or, I mean, they had, yeah. So in an addition reaction, you're going to get rid of the double bond. So the double bond would break for both carbon atoms. And the carbons would be short of a bond, so they're going to connect with each other. And this thing would continue. Lots of thousands and thousands of molecules would join up. Okay? So just 1 minute break. Okay? Just 1 minute. I'll be back in 1 minute. So let's continue. Can you hear me? Hello.
Yes, sir.
Yes, sir.
Acha. So ये clear है? Is this clear? Addition polymerization. ठीक है?
Clear.
Yes.
So I'm just going to do one more example, ठीक है? Just for practice that you have. Let's say you have uh, butanene, for example. There's a double bond here, and there is H and another H, and there's CH2 and CH3. So if you have this, how would you draw the polymer? That around the double bond, nothing right and left side, nothing should be drawn. So what I'm going to do is bring this entire chain from the right side, and I'm going to bring it pointed downwards. I'm going to bend it. Okay? I'm not going to break the molecule. And the other side, I have a hydrogen atom. I'm just going to bring it and bend it downwards. So the molecule would look like this. There's a double bond with HH. The CH2 CH3 chain would now be on the, instead of being on the right side, it would be on the bottom, and the same would be true for the H. The H would be pointing downwards as well, and the double bonds would break in the middle, so that would go, and the carbons would start linking up with more of these repeat units. So the other way of representing this molecule is by just writing N. That's the other way of representing this molecule. Okay? Is this clear? Ethan, is this clear?
Yes, it's clear.
Okay. As the next one. The next one is gases produced in internal combustion engines include carbon monoxides, oxides of nitrogen, and unburned hydrocarbons. These gases are removed from the exhaust before they can enter the atmosphere. State what is used to remove these gases from the exhaust. So there's platinum or palladium catalyst. Okay, and I've actually forgotten the name of the thing. It's a honeycomb structure. And I have just one second. I have the notes of it. What is it called? Does anyone remember the name?
Is it a catalytic converter?
Yeah, it's called the catalytic converter. Okay, so it's called the catalytic converter. Okay, all these, and what happens, right? One equation to show how both carbon monoxides. What actually happens is uh, that nitrogen oxides and carbon monoxide. The carbon monoxide is, why is it poisonous? Because it combines with the hemoglobin in the blood and causes choking, and it can kill a person very quickly. So it's very poisonous. Carbon monoxide gets converted into the safer version, which is carbon dioxide. Although it is also a pollutant, it causes global warming, but at least it's not poisonous. The nitrogen oxides, they get converted into nitrogen gas. You can balance this equation. That's the reaction that would be happening in the catalytic converter. State the environmental consequences of allowing unburned hydrocarbons to enter the atmosphere. So one of them would be acid rain. I mean, that's the only one, because the problem caused by carbon monoxide is not an environmental problem. Uh, it causes choking, but that's not an environmental problem. Nitrogen oxides, they can react with rainwater to form acids along with sulfur oxides. So nitric and nitrous acid would be produced in the reaction. But anyways, it was just a 1 mark question. Then he's saying vehicle fuels are treated to remove sulfur. If sulfur is present in a fuel, SO2 is produced and may be released into the atmosphere where it can form acid rain. Acid rain can contribute to breathing difficulties. Identify 2 other consequences of acid rain in the atmosphere. Anyone, any idea? What does acid rain do?
Does it corrode?
So one is it corrodes buildings, limestone. buildings and metal structures.
And can affect aquatic life.
Exactly. So the soil could become acidic. Soil and water bodies can become acidic.
Corrodes limestone building.
ठीक है. You think your mic is on? As soil and water bodies, they become acidic. Uh, Now, NO2 is involved in the production of acid rain from SO2. Give two equations which describe how acid rain is formed by the action of NO2 and SO2. Uh, Remember this, NO2 does two things. It first acts as an oxidizing agent. It converts SO2 into SO3 and gets reduced itself. But the NO in the atmosphere gets oxidized again to NO2. So NO2 is acting as a catalyst in converting SO2 into SO3. So give two equations which describe how acid rain is formed by the action of, and I think there should be a third equation where it reacts with water to form. I mean, on the safe side, we should write the third equation. I can check whether the third one, but it has to be given probably. So where's the? Take this one. So, but here the third one is also given. That was what because they were talking about forming acid rain. So the SO3 reacts with water to form H2SO4. Next one is explain the use of an appropriate equation why NO2 is described as a catalyst during this process. It remains unchanged and speeds up the reaction. So he's saying, I mean, we've already written down the equation. Let me check what they're asking for this in this one. This is the equation which we mentioned earlier. That's written over here. And so they were asking for this equation and 1 mark for that it is regenerated or is not used up or remains unchanged or is recovered unchanged. So that had to be mentioned over here. So this equation over here should have come at this point. Next one is the reaction. I said, remember one thing about this, that when you get questions like these where you might, I mean, these two questions are really overlapping questions because this part is also talking about this part. So sometimes what happens is that some people might write an equation over here which would probably be needed over here. You're not going to lose marks for that. Examiners are lenient; they would understand that this equation has already been written, although because these were very overlapping questions. So the next part is now this one is mostly organic, which we are still doing. Let's so here we're done with this paper. Let's start a bit of the MCQ paper. I've left the organic part here. Uh, just 1 second. So these are the MCQ questions. Starting with the first one, they're saying which feature is present in both ethene and polyethene. Now, ethene has a double bond, and polyethene, which we just did, the double bond breaks up. And connects with other molecules of the same type, and they link up, and a polymer is formed. So what's the common feature that's present in both?
Sigma covalent bonds.
Okay, so they both have sigma covalent bonds because sp3 hybridization. Which one has sp3 hybridization out of the two?
Ethene.
Polythene. Polythene.
This one.
Yes.
Okay, this one is sp3. This one, on the other hand, is when it's bonded to three atoms, that's sp2. Pi bonds, these are your pi bonds. Double bond, you have a pi bond. Bond angle is 109.5. That's also going to be sp3. Now, next one, electronic configuration of a sulfur atom is shown. How many valence shell and unpaired electrons are present in one sulfur atom? So, how many valence shell electrons are there? So, this is the third shell. That's your valence shell. That's obviously six. And how many unpaired electrons are there? So, 3p4 would be written as, it's going to have three orbitals. And how would you write four electrons? That would be 2, 1, and 1. So, you're going to have two unpaired orbitals. Next is, in which pair does the second substance have a lower boiling point? So tell me what is the force, intermolecular force in this molecule? It only
Induced dipole, temporary dipole.
it only has van der Waals forces because carbon and hydrogen bonds are not very polar. What's the intermolecular force in this molecule over here?
Permanent dipole.
It's going to have
Uh,
permanent dipole because the carbon hydrogen bonds are non-polar. They have almost the same electronegativity. But the Cl is very electronegative, so it's going to pull the electrons on towards this side. So this side would be negative, and the rest of the molecule would actually be slightly positive. So there's going to be permanent dipoles as well. And permanent dipoles are stronger. So the second molecule would actually have a higher boiling point. It's going to have more attractive forces, right? Okay, is this clear to everyone?
Yes.
That's the next one. What about this molecule? What intermolecular force would be present in this molecule?
hydrogen bonding.
Okay, so that's going to be hydrogen bonding. Whenever you have O and H bonded together, the lone pairs on oxygen, it's a highly polar polar bond, and because of the lone pairs, the negative charge would be very strong. So two alcohol molecules would be attracting each other very, very strongly. So there's going to be very strong force of attraction between them. So this is, I mean, there's nothing stronger than hydrogen bonding. So this is obviously the one that would have higher boiling points. This other molecule, CH3, and there's O, and then there's another CH3. That would just have dipoles because the oxygen is not bonded to hydrogen, it is bonded to carbon. It's going to be negative, but it's the negative charge would be a lot lesser. I mean, the bond is not going to be very polar because the oxygen is not bonded to, it's not bonded to hydrogen. Okay, is this clear?
Yes, sir.
Mom, okay. Achha, what about this one? Argon and neon, they're just single atoms. What type of intermolecular force would they be? I mean, there's a single atom. Ethan, any idea? Mohammed? Anyone?
Sir, van der Waals force is a tempered dipole indeed.
Exactly, because there is no electronegativity. I mean, there's only a single atom, so there's no electronegativity difference. There's just a single atom with electrons, a bunch of electrons around it, and the electrons would be fluctuating, sometimes going this direction. I mean, during collisions, sometimes this would be negative, sometimes this side would be negative. So there would be just temporary dipoles because of the random fluctuation of electrons around it. I mean, there's no other atom around it. So argon is a bigger atom, so it's going to have more van der Waals forces. इसका जो आंसर होगा, the answer would be the last one. That this one over here would have van der Waals forces, and the first one is going to have hydrogen bonding. Because when N and H are bonded together, that is also when hydrogen bonds are formed. Right? Is this clear to everyone? Maza, is this clear? So the last one says That compound J burns in excess oxygen to give carbon dioxide and water only. When a 3-gram sample of compound J is burned in excess oxygen, it produces. So there's some compound J that's burning in oxygen, and it's producing carbon dioxide and H2O. Now, what is provided is that you're given the amount of carbon dioxide that's getting. I mean, there's 3 grams of this, and there's 4.4 grams of carbon dioxide. Okay, that's given over here. I can find the moles. The moles would be 4.4 divided by the MR, which is 44. So it's going to give me 0.1 moles. I said, what about the other one, H2O? It's 1.8 grams of water. So the moles of water would be N divided by 1.8. And the MR is 18 for water. That's also going to give me 0.1 moles. So uh, so that's that's what you're getting, carbon dioxide and water. What do you think the carbon and hydrogen ratio is in this molecule? Remember, where is all the carbon coming from and where is all the hydrogen coming from?
From J.
Okay, it's coming from J. So what's the ratio? I mean, the carbon dioxide and water molecules are being produced in the same ratio. So that means if
What?
2:1.
what is two?
J.
Nini, 2:1. How many carbons? How many hydrogens?
No, wait.
I mean, what's the ratio? It's 1:1, right? Like I'm going to write this neatly that J produces, after burning away the oxygen, it produces 1 molecule of carbon dioxide and 1 molecule of water, right? Now we're assuming that the oxygens are coming from O2, okay? So and the carbon and hydrogens are basically coming from J. So there's 1 carbon and there's how many hydrogens? 2 hydrogens, right? Yeah, the clear, is this clear? Ibrar, is this clear?
Yes, sir.
Okay. Is this clear? Mohammed?
Yes, sir.
That's because you're getting the same moles of carbon dioxide and the same moles of water. So that means that the carbon and hydrogen ratio is going to be, J is going to have 1 carbon and it's going to have 2 hydrogens. Ethan, is this clear?
Yeah.
Okay. Abba, is this clear? Everyone, is this clear?
Yes, sir. So I just have a question regarding water. If the moles of the water were double of that of carbon dioxide, then what?
The question hasn't completed yet, actually.
Acha.
Why your question? What if the ratio was? I mean, you're saying that what if the ratio was there was 1 carbon dioxide being produced, and let's say 2 water molecules being produced, right?
Hmm.
So, what would be the formula of J? I mean, because the carbon and hydrogen atoms are, I mean, the carbon and hydrogen atoms over here are coming from J, right? So, if there's 1 carbon over here, there must be 1 carbon in J. Do you get this point, Ibrahim?
Yes.
Or how many hydrogens do you have? 4 hydrogens, so there would be 4 hydrogens over here.
That's right.
Okay. Acha, but the question is not actually complete. I mean, you found, but hopefully this is clear to everyone that the ratio of carbon and hydrogen is CH2. But the issue now is, does J have oxygen in it or not? Okay, remember this. I mean, that's the tricky part. I mean, it could be C, it could be D, because we don't know what J is. What we know for sure now is that I mean, the carbon and hydrogen in carbon dioxide and water, that's definitely coming from J. Uh, and we know that they're being produced in the equal ratio, equal amounts. So the ratio would be there's going to be 1 carbon and there's going to be 2 hydrogens. That is what we are sure of. What we are not sure of is, okay, does J have oxygen in it? So what is given is that you have how many moles of so what you have is, so I'm going to do some calculations now just to confirm this. What's given is that I know that 0.1 moles of carbon are coming from I mean, that's for sure. They're coming from J. I mean, all the carbon over here, that's coming from when 3 grams of J reacted with oxygen. So the carbon over here, 0.1 moles of carbon, that's coming from J. And I know that 0.1 moles of the H2 in the H2O molecule, that is also coming from J. So what is the mass of zero point 0.1 moles of carbon? That's if you multiply it by the AR of carbon, that's 12. So that would give you 1.2 grams. And the two hydrogens, that would be 2 into zero point 0.1, that would give me 0.2 grams. So if J was CH2, that only gives you a total mass of 1.4 grams. But they're saying that J had a mass of 3 grams. So the carbons and hydrogens, they don't sum up to be equal to 3 grams. Is this point clear?
Yes, sir.
Yes.
Abba, is this point clear? Basra, Ethan, is this clear?
Yes.
Okay, so the point is, so the point was that I figured out that they were being produced in equal ratio, and I for sure knew that the carbons and the hydrogens, because there's nothing else where they would be coming from. So I was very confident that the carbon and hydrogens were coming from J. So I figured out the mass of the carbon, zero point 0.1 moles of carbon and 0.1 moles of the two hydrogens. I just multiplied by the AR, 2 into zero point 0.1 and 12 into zero point 0.1. So the mass wasn't actually coming out to be 3 grams. So that means that apart from the carbon and apart from the hydrogen, there must be something else in it. And there's only one option, which is D. So I knew the ratio. It's going to be C and two hydrogens. I knew that ratio, but I've now figured out there must be something else in J. So the formula of J is probably CH2, and there's going to be oxygen in it as well. Okay, is this question clear?
Yes, sir.
Clear.
Okay, let's do another one. The gases X and Y react to form Z. An equilibrium mixture of the three gases is compressed. I mean,
Yes.
did anyone ask a question? Acha, so equilibrium mixture of these three gases is compressed at constant temperature. What will be the changes in the mole fraction of Z and in Kp? So remember that equilibrium constants, they only change with temperature. Only change with temperature. Kp is not going to change. The value of Kp is not going to change. What is Kp? Kp is going to be the pressure of the products, which is Z in this case, divided by the pressure of the reactants, which are going to be X and Y. So they're saying, what happens to the mole fraction of Z now? So one thing is clear, that Kp is not going to change. Remember that the value of Kp and Kc, it only changes with temperature. That's the only thing that changes the equilibrium constant. Otherwise, the equilibrium constant is a constant, which is why you use the word constant. Never changes. But the other part, now he's talking about the mole fraction. So can anyone tell me where would the equilibrium shift if you increase pressure?
To the right.
Left.
Yeah,
Sorry, right.
Right.
so you're compressing it, so it's going to go to the right, right? So there's going to be more Z, right? What is mole fraction? Mole fraction of Z. Mole fraction of Z is the amount of moles of Z divided by the total moles, right? So it's the amount of moles of Z divided by the total moles of gas present in the container. So if it shifts to the right, that means the moles of Z are going up. You have more moles of Z, and the total moles of the gas would actually decrease, because 2 moles of X and Y would react to form 1 mole. So the total moles of gas would actually decrease. So this would actually be going down. Is this point clear?
Sir,
Yes.
the second part of it is not clear. How's the total mole decreasing?
Yeah, because one molecule would react with one molecule to produce one molecule. So basically, two molecules are reacting to produce one molecule.
Achha, alright. Okay.
So total moles are decreasing because if the equilibrium is shifting right, so the amount of reactants are more, and the product that is formed, the amount of moles are lesser. So two molecules are reacting to produce one molecule. Okay. Uh, so what's the answer? This one probably B. Okay, it's going to be B. And let me check whether it is B. Okay, it is B. So the next one is, which gas is likely to deviate most from ideal gas behavior? Now, ideal gases had two assumptions. One of the most important assumption was that they had no intermolecular forces. I mean, negligible, basically, not no intermolecular force. What it stated was that they had negligible intermolecular forces. Uh, and the second point was that the intermolecular distances were very large, which meant that there would be large gaps between the particles. And the way that was phrased was that the volume occupied by the particles is very less compared to the volume occupied by the total gas. So gases would be very far apart from each other. That was the second assumption. Now, if any gas has very strong intermolecular forces, which is true in this case, I mean, this has permanent dipoles, whereas all the other ones, they have weak van der Waals forces. So permanent dipoles, it's going to deviate a lot. And why would it deviate? The reason it's going to deviate is, what's the reason why it deviates? It's the reason is that if you have a gas in a container and the gas particles, and we're assuming that the gas particles don't attract each other. So these particles are going and they're trying to exert a pressure by colliding with the walls of the container. So if there are no intermolecular forces, a certain amount of pressure would be exerted by these gas particles. But if there are intermolecular forces, then what's going to happen is that the particles would slow down. Because if one particle is going to the right over here and it's trying to hit the wall of the container, then there's a particle from the other side that is attracting it or pulling it back. So since it's pulling it back, the attraction would be, I mean, it's going to slow it down, and the particles would hit the walls of the container with a lot lesser speed. Do you get this point, Ethan? Is this point clear? Ibrar, is this clear?
Yeah.
Yes, sir.
चलो ठीक है. अच्छा, we'll continue with this, ठीक है, later on, the same paper. So we're going to end the session now, ठीक है? Any questions about any of the questions that we did? And I'm going to send you the inorganic worksheet. Sarah, clear? Isa, is this fine? Clear? Basga?
Yes, sir.
ठीक है. So, okay then. Take care. And if you have any questions, you can ask me those questions. ठीक है? Okay, take care. Allah Hafiz.
Allah Hafiz, bye.
Allah Hafiz.